Although hazardous materials containers are generally safe and reliable, accidents do happen, and sometimes hazardous materials are spilled. Spills involving hazardous materials can rapidly escalate and require immediate attention.
It appears we have gasoline in the barrels.
The purpose of this program is to show you how to confine spills using a variety of materials and methods. The learning objectives are to present safety considerations in spill control operations, to discuss spill control basics, to show equipment and materials needed, and to demonstrate basic techniques for diking, diverting, damming, and retaining spills. Safety rules are especially important in spill control operations because responders are usually heavily exposed to hazardous materials.
We got an overturned rail car.
As with all hazardous materials incidents, identify the product before you proceed. It is essential to know what you are confining so you can make decisions about personal protective equipment and spill control procedures.
1202.
Fuel oil, diesel fuel.
You should know the chemical and physical properties of the product as well as its name. Chemical properties describe a product's ability to undergo a chemical change or reaction, such as when a product is corrosive, flammable, or reactive. Chemical properties also give clues as to what type of spill control techniques will work. For example, flammable liquid products should be diverted away from the incident scene and exposures as quickly and safely as possible. Combustible should be removed from the vicinity of a corrosive spill, or the spill should be diverted away from combustibles to limit the risk of fire. Physical properties describe a product's observable or measurable physical aspects, both inside and outside a container, such as density, or whether it is lighter or heavier than water, miscibility, whether it will mix with water, and solubility, whether it will dissolve in water. You should also determine how the product reacts with water and other materials it might contact. Use water with great care. Water can be helpful in diluting some products, but it can also spread the product or react with it, generating toxic vapors. Some products are so dangerous the contaminated water and soil must be disposed of as hazardous waste. Because this type of cleanup is expensive, try to keep personal and environmental exposure to these products to the absolute minimum. Spill control often requires heavy physical exertion under time pressure and is exhausting work. Know the physical limitations of on-scene personnel and plan for a sufficient number of responders as well as sufficient rehabilitation and air supply resources. Use mechanical equipment whenever possible. Work smarter, not harder. If you only have a handful of firefighters at a large fuel oil spill, it may be more realistic to protect the storm drains and call for backup, rather than attempt to dike and retain the entire spill. All on-scene responders must be properly protected against exposure to both the product and its vapors when working on spill confinement. It is difficult to dig and sandbag in full protective clothing and self-contained breathing apparatus, but without such protection, firefighters can easily be overcome by fumes or direct exposure. Always wear the proper PPE for the job. The primary objective of hazardous material spill control is to stop the flow of product in order to protect life, property, and the environment from contamination. In general, the product should be confined to the smallest possible area, as close to the source as practical, to make cleanup and removal easier and less expensive. However, Flammable liquids should be channeled away from the incident site, all exposures, and potential ignition sources wherever possible. Take all possible measures to prevent spilled product from entering water and sewer systems. Both natural and man-made water systems should be protected. Groundwater under the soil can also become contaminated if the product leaches downward to the water table below. There are a few general guidelines for hazardous material spill control that should be remembered. First, attempt to control the release at the source as soon as possible. It doesn't make sense to keep digging when you haven't tried to stop the leak. In some situations, you will not have the equipment or training to shut off the source of the leak. In these instances, call for technical assistance immediately. You may be able to obtain assistance from public works departments, hazardous materials or environmental protection agencies, and industry resources such as Chemtrec. Keep the phone numbers of technical assistance personnel in your response vehicle. Second, always perform confinement measures in advance of the leading edge of the spill. Build a diversion dike or a retaining basin in the area where the spilled product is going, not where it is now. With most flowing products, if you attempt spill control operations behind the leading edge of the spill, you will become heavily contaminated, and the product will be far beyond your confinement area by the time you finish. Third, be realistic about the time needed to perform confinement operations. What seems like a simple task may take much longer than anticipated. In order to properly estimate the time, personnel, and equipment needed to confine a spill, you should practice and perfect confinement operations. The equipment and materials used for spill control include many items you already have, as well as others you could easily acquire. Equipment can range from a shovel to a bulldozer or backhoe. Because confinement operations are almost always a race against time, you may have to use shovels to move large quantities of dirt if heavy equipment is not available. The materials you use can be cheap, such as readily available dirt, or more expensive, such as commercially available booms. Firefighting hose, inflated with water or air, then capped, can be used to quickly create dikes or booms. Wrap the hose in plastic if you are able to prevent it from becoming contaminated. In rural areas, straw or hay anchored with a few well-placed pitchforks can slow down product flow. Other materials that can be quickly used include both absorbent and adsorbent materials. Absorbent materials soak up and become saturated with the product. Common materials used to absorb spilled product include vermiculite, peat moss, and clay granules such as kitty litter. Adsorbent materials do not become saturated, but instead collect the product chemically. You may find absorbents and adsorbents in the form of particulate, sheets, pads, pillows, and booms. Before using any material, make sure it is compatible with the spilled product. Additives in kitty litter can make the problem worse, and organic materials such as straw can combust and cause a fire when in contact with some hazardous materials. If your department wants to put together a spill control kit, review the types of hazardous materials present in your jurisdiction to determine the most likely products to be spilled and where they are stored and used. Also, consider hazardous materials that frequently travel through your jurisdiction, as many spills are the result of highway accidents. Your spill control kit should include equipment and supplies, as well as a list of where to quickly get what you do not have. Be prepared by knowing who to call and where to go before a spill occurs. Diking, diverting, damming, and retaining often follow a progression. Depending on available time, personnel, level of training, and equipment, you could use one method or all of them. Two of the most common spill control techniques include diking and diverting. Diking uses a barrier to block the product from entering a vulnerable area. Dikes may be constructed by heaping dirt or other materials higher than the flow of product. Some diking materials are prefabricated, such as sandbags or sorbent booms. There are two common dike shapes, the circle dike and the V-dike. The circle dike completely encloses the material. It is usually used with slow-moving materials. The V-dike is used for faster-moving products when there is not enough time to completely enclose the spill. Be sure the walls of the V-dike are long enough to hold the product within the confinement area. Use whatever on-scene resources are available. Build dike walls by first laying out large, heavy materials, such as tree limbs, boards, ladders, or bagged materials. Add a layer of plastic sheeting or tarps, which will slow seepage. Apply an outer layer of dirt, including along the leading edge of the sheeting. Some incidents may require that you build the entire dike out of dirt, but this is very time and energy consuming, especially if you do not have mechanical equipment. Also, a solid dirt dike creates a greater waste removal and decontamination problem than one made of large materials covered with dirt. Diverting involves redirecting the spilled product to another area where less harm will result from contamination or where it can be properly retained until cleanup crews arrive. To divert the product, position a diversion dike in advance of the spill so the product will flow in a different direction. This can be accomplished by shoveling dirt into a solid barrier. It is generally best to have at least 3 responders work on preparing a diversion dike. The first person breaks the ground, the second person digs the dirt into a pile, and the third person packs the dirt into a solid dike. The diversion dike should be constructed so that it will control the direction of the spill, yet not be so large and complex that it strains the physical limitations of the firefighters. Determine the angle, height, and length of the diversion dike according to the speed and volume of the spill. For fast-moving spills, an angle of 60 degrees or more will be needed to slow it down. Important spill control techniques also include damming and retaining the hazardous product. Damming involves constructing a barrier across a waterway to stop or control product flow. Think of damming as going across, where diking goes around. Dam types include the overflow dam and the underflow dam. Overflow dams trap material heavier than water behind the dam, allowing uncontaminated water to flow through near the top of the dam. Underflow dams trap material lighter than water behind the dam, allowing uncontaminated water to flow underneath the dam. An underflow dam may be constructed similarly to an overflow dam, with pass-through pipes placed low to allow water to flow underneath the hazardous product. Retaining temporarily confines the product in an area where it can later be absorbed or vacuumed up after dilution or neutralization. Some retention methods involve creating a basin to capture flowing product. Other retaining operations may include securing a storm drain or manhole cover from the spilled product. Lay a sheet of plywood or plastic over the storm drain or manhole cover, extending at least 8 inches or 20 centimeters around the outer edge. Build up a circle dike of sand or soil so that one half of the dike is on the pavement and one half is resting on the plywood or plastic sheet. The product will flow around the dike. Another method of protecting a storm drain or manhole cover is to lay down a sorbent boom in front of the entrance. Pile dirt or foam that is compatible with the spilled material around the outside edge of the sorbent boom. The product will be slowed by the dirt or foam, and any product that seeps through will be collected by the sorbent boom. This method can only be used with small spills because large volumes of product could spill over the top of the dirt and the boom. In this program, we have discussed the safety considerations that are critical in spill control incidents involving hazardous materials. We have discussed spill control basics you will need to know ahead of time. We have shown equipment and materials that can be used for containing spills. And we have demonstrated diking, diverting, damming, and retaining techniques for controlling spilled hazardous materials. It may not be very glamorous work when you're hefting a shovel in full protective equipment on a hot day, but by preventing large-scale contamination of the environment, you are the last defense between an incident and a disaster.